Hi, good afternoon, everyone. I'm Philippe, Lemarchand, the head of sustainability intelligence in TU Dublin. And my team and I actually have started a project called Towards Sustainability University Campus. That is an HEA-funded project that started about 2 years ago. It's a 3 years project. And through this project, we are looking at the digital transformation of our buildings. And that actually identified a few challenges, and we actually defined a few approaches to address these challenges that I'm going to talk about. So the first thing is that our project totally aligns with basically European, national, and institutional policies that are on climate, digitalization, and education. All those actually trickle down towards TU Dublin sustainability strategies. One thing that is actually important is that actually from January 2025, since actually building information modeling is mandatory for all public projects that are above 20 million euros, and we know actually that this threshold is actually going to change. So that makes BIM very important. But the problem is that it's actually very costly, very time-consuming, and there's a huge gap in knowledge, skills across all institutions. So we needed to address them. So our TSUC project aimed to actually identify the steps and challenges to actually digitalize our buildings. We wanted to predict the cost and benefits actually associated to these challenges. We needed to acquire the skills and knowledge that are necessary to actually going through this process. And we also took the opportunity to obviously upgrade our technological solutions. So we did that through piloting a scalable digital system that looks at energy monitoring, optimization, and reporting over 3 buildings in TU Dublin. Those are on 3 campuses. There are 3 different types. They are from small to large scales, and because of their different age, they actually represent different technology readiness level, which is a massive issue when you're trying to do that onto existing buildings. So some of the other goals actually of our project looked at first benchmarking the energy performance and comfort and the occupancy profiles. We want to develop energy comfort and occupancy models. We wanted to transform our buildings into interactive living labs, and finally develop initiatives to upskill staff, even students, researchers, everybody actually, and communities. So to do that, we actually went through a general development process that first looked at mapping all the European, national, and institutional reporting needs, which actually led to monitoring needs. And that actually informed basically the data gap that we have, the governance gap, and even the data governance gap that we have, to then look at every building digitalization technologies that we need to apply to actually go through the process, and then look at how to actually operationalize, so meaning how to scale a pilot project to all the buildings that we have across TU Dublin. And that is actually going through huge engagement with all staff, function staff, but also education, also research. So it's a huge piece of work. And all through this process, we actually have the opportunity to identify more gaps, more issues, more challenges, and use SWOT analysis to actually then amend various policies and strategies within our own institution, but even nationally. So when I look here at the challenge and approach to data and governance, that's just because it's typically just the tip of the iceberg, hence the drawing. So the first layer of challenge is actually related to data privacy and cybersecurity, like we have heard already. And actually the easiest approach to actually solve that issue is obviously to maintain all our data within Europe. We don't let it leave Europe framework. As long as we are under the European laws and regulations, for sure we're going to do it right by ensuring that everything is private and cybersecurity. And obviously we also need to comply with our local data compliance and data governance, even institutional. A bigger challenge here is actually to create a very robust data architecture. Because nowadays, all the data that we have are very siloed. They are siloed across multiple functions, across different systems, and then that creates another problem, is to actually know if the data that we need already exists. And once you know that they exist, how do you access them? And once you access them, you need to interconnect them. So there's a whole list of challenge, and so the easiest approach that we have actually developed is the development of a data management platform that is actually using data lake technologies. So another point is actually we needed to build this data culture, sharing culture. So that's for the engagement, and particularly I'll talk about later about Living Lab. But then we actually identified there's a need to actually transform a few of our procurement processes, particularly because we have many service providers. Every service provider holds data. We need to actually get this data and interconnect them to make use of it with the rest of the data. So that brings to another point that was addressed previously, data quality, treatment, and traceability always being a challenge, right? So again, data lake technology can actually solve partially the problem because obviously that's very evolutive and that's very transformative. And obviously we need to use AI and machine learning tools. But it also means that we also need to define very specific transformation process of our data and have clear analytical methods to understand our data and actually compare data from building to building, campus to campus, institution to institution, country to country. I mean, everything needs to be clearly defined. We all need to have the same method, so to create this robustness. So finally, another challenge is about data responsibility and accountability. So here, actually, that means that we need to build the data governance document and actually process that is really tailored to building digitalization. And that means involving all the stakeholders, so across functions and so in education, in research, across operation, but also all the different groups that we have within university, like I mentioned, the University Sustainability Councils, the different advisory board, transformation boards, even the executive team and the government body. So there's a huge amount of people, and there's a responsibility and accountability all across, right? So here in this picture, I want to address a few technological and service challenges to building digitalization, and it starts with our legacy systems that are very much heterogeneous infrastructures, typically outdated technologies. So that brings a whole list of problems regarding data communication protocols, data format, and how to integrate those data with new technologies, right? And the new services. That is also very costly to actually do, and that actually brings me to my second point, where we have really a gap between the budget that we have available and the high service cost in general. So many times we have to actually downsize our ambition. So because this integration of data into of systems and maintenance and the upgrade of such systems is highly costly. And just as an example, I find that laser scanning actually detailing beam models is one of the most expensive when we actually is just one component, one technology into many other technologies that we need to use for building digitalization. So obviously these budgetary gaps create many delays, it increases many risks to actually fail on the project timelines and not meeting our climate targets. So we have a bit of an issue. Then we also have a challenge regarding lengthy administrative process. So I just listed a few there. But there's a few solutions that I will mention after. So very heavy slides, but because there's a lot to be talked about, we have many technological approaches to actually solve this challenge. So first, building assessment, that means that we need to actually do the U-value measurement of our buildings, we need to do the air tightness testing, we need to do thermal imaging, and that is all very useful actually to create the calibration of building physics models, right? And then we can use that to actually validate the contracted design with actually properly built buildings. Then the next step is actually looking at mapping and adding sensing equipment. We need to align those with digital models, with live data, and in particular with the KPIs that we need to report on that are at an institutional level and down to international levels. Those are absolutely necessary to ensure that we have the accuracy needed for our simulation and the prediction and the daily operation of the buildings. We need to upgrade our BMS. is quite intensive. That is obviously key because that manages our building operation, maintenance, and asset data. But data integration is even harder, right? Because we need to integrate those with other technology services. Like, for example, we need to integrate, I don't know, access control. We need to integrate academic timetabling, time schedule. It could be anything that is impacting the operation of the buildings, particularly the occupancy of the buildings, and affecting the energy consumption, the optimization of the buildings. So there's a lot to be done there. Then, obviously, we finally tackle building information modeling. There, actually, the key point is that we need to look at it and to find the minimum level of details that we need to actually lower the cost, but still maintain the information that is required to actually make use of it and to make sense of the data. So there's a bit of a trade-off that is very complicated. And that should also help us at accelerating the development of building physics models. Those are actually extremely important, obviously, to simulate thermal, energy comfort, and energy performance. And they are there to enhance design and operational efficiency by simulation. Finally, after all that, that's when you can actually take all this data and actually bring them to digital twins to actually create these dashboards that are very useful. They are actually enabling to have a monitoring of your live buildings, perform the analysis, identify where is this gap coming from, so you can regenerate new insights, and then develop new energy conservation measures onto the building to lower the carbonization impact of the building, the greenhouse gas emission. And then we have a few approaches to cost and financial issues. So it starts first with looking at consolidating all our projects and tasks and strategies with mapping the resources. But then we need to upgrade and add all the equipment that is necessary in phases. And here the strategy is important, like which one is the most important of sensors that I need, which equipment needs to be sold first. Then we need to it's highly recommended, recognize and avail, which is the issue here, insight, skills and knowledge, right? We have huge amount of skilled people in the universities, for example, but they're all on the time limit, and even we want to actually make use of them is very difficult. But we need to emphasize that. Utilize predictive models to identify cost-effective solutions, hence the building physics models and all the digital twins. We need to forecast actually the minimum and desired requirement and associated cost to scale basically our budget to our budget. Then the data management platform and the facility management system that I'm not going to really talk about here is extremely useful to actually streamline administrative process, because that means we can define all the digitalization steps, we can assign staff responsibilities, and finally we can track progress. Another piece of challenge is regarding operationalization. So when it comes to take our pilot project and really upscale it to all our buildings, and it starts with competing priorities, because whereby we actually need to balance the education priorities and objectives with the different finance objective and limits, and the operational efficiencies to finally meet the climate, digital, and educational agendas. Then there is also a resistance to change from different staff, and change is obviously very disruptive, and it creates very much period of instability and uncertainties, but we really need to embrace them. And some of the resistance to change is actually originated from the skill and knowledge gaps, right? And here, one of the challenges is that there is no building digitalization training that is tailored to specific staff role and responsibilities. Right now, we just produce general things, but it's not going to make full impact if it's not tailored to the person. So that means that we also need to demonstrate values and provide clear return on investment and tangible benefits to sustain engagement and funding. So our approach to actually enable the operationalization is through the Digital Living Lab, and that is to foster inclusiveness, acceptance, and cross-functional impact. It starts with institutional strategy alignment, like we have previously discussed. We need to create these tailored training programs. We need to create the knowledge transfer, and we already do that by taking out the learning of our project and started to tailor our curriculum and the different modules that we are teaching to teach the next generation of skilled workers. Then we actually use the learning of a project to create new research projects, new research proposals, and we actually use basically all this user-centric dashboard to inform a whole lot of stakeholders that needs to be made aware of the impact on the operation of the buildings, and that is part of the knowledge transfer. Then daily collaboration is extremely important, and here we are really closely collaborating with estates, with campus planning, and the different functions of the university in academics, like different schools, different research units. But we also obviously closely collaborate with many industries, and in particular also community of practices. And I'm just going to stop here, leaving you a few key takeaways, and just thank you very much for your attention.